Welcome to our online class. This is Ma'am Teresa Tubal. Join me to enjoy mathematics. Are you ready to learn about the arithmetic series? Let's go. Question number 1. How many chocolates are there? Any idea? Correct. The answer is equal to 10 because 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 that is equal to positive 10. Question number 2. How many Jews all in all? Can you count all? Correct. The answer is equal to 20 because 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 that is equal to 20. How about question number 3? How many cornetto ice cream are there? Can you count? Correct. The answer is equal to 16 because 7 plus 5 is 12, 12 plus 3 is 15, 15 plus 1 that is equal to 16. Let us recall about the arithmetic sequence. Question number 1. What is the next term of the arithmetic sequence 14, 20, 26, and 32? A is 36, B is 41, C 40, D is equal to 38. Any idea what is the answer? Correct. The answer is equal to 38 because 14 plus 20 is 6, 20 plus 6 is 26, 26 plus 6 is 32, 32 plus 6 that is equal to 38. Question number 2. Find the common difference of the arithmetic sequence 2, -3, -8, and -13. Any idea what is the answer? Correct. The answer is equal to -5 because -3 minus 2, that is add, so that becomes -5. Or -13, change the sign, plus 8. So -13 plus 8, that is also equal to -5. Question number 3. Which term is equal to -35 when the arithmetic sequence -8, -11, -14? A 10 term, B 9 term, C 8 term, and D is 7 term. Any idea what is the answer? Correct. The answer is equal to 10 term. Question number 4. The first term of an arithmetic sequence is 3, and the 20th term is -4. What is the common difference of the sequence? Can you solve? What is the answer for question number 4? Correct. The answer is equal to -3. Which of the following is the 43rd term of the arithmetic sequence 3, 0, and -3? A, -117, B, -120, C, -123, D, -126. What do you think is the answer for question number 5? Correct. The answer is equal to -123. Arithmetic series is the sum of the terms of an arithmetic sequence. What do you think is the sum of this arithmetic sequence 2, 4, 6, and 8? 2 plus 4 is 6, 6 plus 6 is 12, 12 plus 8 that is equal to 20. Let us see what is the strategy of one of the greatest mathematicians along with Archimedes and Isaac Newton. He is Carl Friedrich Gauss. The teacher tells Gauss to add all integers from 1 to 100 to make him busy. The teacher surprised that Gauss was able to quickly add all the numbers from 1 to 100. Gauss add more quickly than expected. As you can see, it's not easy to add numbers from 1 to 100. What do you think is the solution of Gauss to solve those numbers from 1 to 100? Let us present the Gauss solution. The solution of Gauss, as you can see, he add 1 plus 100, the first and the last term. He added 2 plus 99, the second term, and the second to the last term. And then 3 plus 98, and so on. And then the middle, that is 50 plus 51. So 1 plus 100, that is equal to 101. 2 plus 99 is 101. 3 plus 98 is 101, and so on. 50 plus 51 is 101. So that is 50 terms in all. So 101 times the 50, so the answer is S sub n is equal to 5050. It means he add all the integers from 1 to 100, the answer is equal to 5050. Let us use Gauss method to find the sum of the given sequence 1, 4, 7, 10, 13, and 16. So as you can see, the solution is 1 plus 16, and then 4 plus 13, and then 7 plus 10. So 1 plus 16 is 17. 4 plus 13 is 17. 7 plus 10 is 17. So how many 17? That is 3. So 3 times 17, that is equal to 51. Or 17 plus 17 plus 17, the answer also is equal to 51. How about the next sequence? 2, 4, 6, 8, 10, and 12. Again, the solution is 2 plus 12, 4 plus 10, 6 plus 8. So 2 plus 12 is 14, 4 plus 10 is 14, 6 plus 8 is 14. So 314, so that is 3 times 14, the answer is equal to 42. Or 14 plus 14 plus 14, the answer is equal to 42. The formula is a sub n is equal to n over 2 times the quantity of a sub 1 plus the a sub n. While the second one, a sub n is equal to n over 2 times the quantity 2a sub 1 plus the quantity n minus 1 times t. What could be the time to use the first formula? The first formula is to be used when a sub n is given. How about the second formula? The second formula is to be used when a sub n is not given. So where n is the number of terms, same with the formula of the arithmetic sequence, a sub 1 is the first term, a sub n is the last term or the nth term, while d is the common difference. Can you try it? Question number 1. Find the sum of the arithmetic sequence 1, 3, 5, 7, and 9. What do you think is the sum? Correct. The sum is equal to 25 because 1 plus 9 is 10, 7 plus 3 is 10. So 10 plus 10 is 20 plus 5. The answer is equal to 25. Question number 2. How about the sum of this arithmetic sequence 10, 15, 20, 25, and 30. What do you think is the answer? Correct. The answer is equal to 100 because 10 plus 30 is equal to 40. 15 plus 25, that is also equal to 40. So 40 plus 40 is 80 plus 20, the answer is equal to 100. Question number 3. Find the sum of the arithmetic sequence 4, 7, 10, 13, and 16. What do you think is the answer? Correct. The answer is equal to 50 because 4 plus 16 is equal to 20. 7 plus 13 is 20. So 20 plus 20 plus 10 is equal to 50. So let us use other solution to solve for the sum of the arithmetic sequence. These are the given. The first term is 4, the last term is 16. The number of terms is equal to 5 because 1, 2, 3, 4, 5. The common difference is equal to 3 because 7 minus 4, that is equal to 3. Or you may use the fifth term minus the fourth term. So 16 minus 13, the answer is also equal to 3. What is the best method to solve this one? The best method is Formula 1. So that is a sub n is equal to n over 2 times the quantity a sub 1 plus a sub n because we have the last term. We need to replace all the value to the formula so that becomes s sub 5 because n is equal to 5. N is 5 divided by 2. The first term is 4. The last term is equal to 16. Add 4 plus 16. So that becomes 20. 20 divided by 2 is 10. So that becomes 5 times 10. The answer is equal to 50. Or 5 times 20 is 100 divided by 2. The answer is also equal to 50. So the sum of this arithmetic sequence is equal to 50. So the sum of this arithmetic sequence is equal to 50. Question number 4. Find the sum of the first 10 terms of the arithmetic series if the first term is 3 and the 10th term is 39. Given is first term is 3, 10th term is 39, the number of terms is equal to 10. The formula to be used is formula number 1 because we have the last term. A sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. We need to replace all the value to the given equation. So that becomes a sub 10 is equal to the value of n is 10 divided by 2. The first term is 3, the last term is 39. So using the PEMDAS, we need to solve the parentheses. 3 plus 39 is equal to 42. Copy 10 over 2. And then we need to divide. 10 divided by 2 is 5, copy 42. So 5 times 42, the answer is equal to 210. So the sum of the first 10 terms of the arithmetic series is 210. Find the sum of the first 20th terms of the arithmetic sequence negative 2, negative 5, negative 8, and negative 11. The first term is negative 2. The number of terms, that is 20. And the common difference is by subtracting the second term minus the first term. So negative 5 minus negative 2 or negative 5 plus 2. So the answer for the common difference is negative 3. The formula to be used is formula number 2. S sub n is equal to n over 2 times the quantity 2a sub 1 plus the quantity n minus 1 times t because we have no last term. Let us substitute all the given to the formula. So that becomes s sub 20 is equal to 20 over 2 times 2. The first term is negative 2 plus, again, the number of terms is 20. Copy negative 1 and the common difference is equal to negative 3. By means of PEMDAS, multiply all the parentheses, so that becomes 2 times negative 2 is negative 4. 20 minus 1 is 19, copy negative 3. And we may divide 20 divided by 2, that is equal to 10. And then simplify. So that becomes copy 10, copy negative 4. 19 times negative 3 is equal to negative 57. Next solution is add. Add the parentheses, so negative 4 minus 57 because we have the same sign, so add. So that becomes 10 times negative 61 and then multiply. So the sum is equal to negative 610. So the sum of the first 10 terms of the arithmetic series is equal to negative 610. Find the sum of integers from 1 to 50. Given the first term is 1, the last term is equal to 50, the number of terms is equal to 50, and the common difference is equal to 1. It is the same with counting from 1 to 50. So the number of terms is equal to 50 and D is 1. So the best formula to be used is S of n is equal to n over 2 times the quantity a sub 1 plus a sub n because we have the last term. So n is equal to 50. So S of 50 is equal to 50 divided by 2. The first term is 1. The last term is equal to 50. Using the PEMDAS, 1 plus 50 is 51. 50 divided by 2, the answer is equal to 25. And then multiply. 25 times 51, the answer is equal to 1,275. So the sum of the integers from 1 to 50 is equal to 1,275. Question number 7. Find the sum of odd integers from 1 to 100. The first term is 1, the last term is 99 because 99 is odd, while 100 is even integers. N is equal to 50 because half is even and half is odd. And then the common difference is equal to 2 because the odd integers is 1, 3, 5, and so on. So if we subtract 3 minus 1, the common difference is equal to 2. What is the best method to solve this one? We have the last term, so the formula is S of n is equal to n over 2 times the quantity a sub 1 plus a sub n. So we need to replace the value of n by 50, so S of 50 is equal to 50 divided by 2. The first term is 1, the last term is equal to 99. 1 plus 99 is equal to 100 using the PEMDAS. And 50 divided by 2 is 25. So multiply 25 times 100, the answer is equal to 2,500. So the sum of odd integers from 1 to 100 is equal to 2,500. Let us recall, arithmetic series is the sum of the terms of an arithmetic sequence. The formula is S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. And the second formula, S sub n is equal to n over 2 times the quantity 2 times a sub 1 plus the quantity n minus 1 times d. The first formula is used when last term is given, while the second formula is used when a sub n is not given. Again, n is the number of terms, a sub 1 is the first term, a sub n is the last term or the nth term, d is the common difference. Any question? I know you learned something new, the arithmetic series. Enjoy learning mathematics. I'm Teresa Tubal. Thank you so much.